Good day everyone, we are CHEMATHRY and today we will present our culminating project. Our chosen field of endeavor is chemistry. This is the outline of our presentation today.
What is chemistry? According to the American Chemical Society or ACS, chemistry is the study of matter defined as anything that has mass and takes up space. Chemistry seeks to understand not only the properties of matter, like the mass or composition of a chemical element, but also how and why matter undergoes certain changes. An exponential function is defined by the formula f of x equals a raised to x, where the input variable x occurs as an exponent. The exponential curve depends on the exponential function and is an important mathematical function. F of x equals a raised to x, where a is greater than 0 and is not equal to 1. X is any real number. In exponential decay, the quantity decreases rapidly at first, then slowly. The rate of change becomes slower as time passes. The rapid growth meant to be an exponential decrease. The formula to define the exponential growth is y equals a multiplied by 1 minus r raised to x, where r is the decay percentage. The formula for radioactive decay is important in radiocarbon dating, in which is used to calculate the approximate date of a plant or animal died. It compares the difference between the ratio of two isotopes of carbon in an organic artifact or fossil to the ratio of those two isotopes in the air. The entire process of radiocarbon dating depends on the decay of carbon-14. This process begins when an organism is no longer able to exchange carbon with its environment. The model depicts the relationship between radioactive material decay and decay time. The time in years is the independent variable, and the percent of radioactive carbon-14 remaining is the dependent variable. The domain is from negative infinity to positive infinity, while the range is all real numbers greater than 0. Any function in which an independent variable is in the form of exponent, they are the inverse function of logarithm. Example, y equals b raised to x can be rewrite into logarithmic form as y equals log x base b. As we can see, the graph is decreasing. It approaches the x and y axis, but it does not intersect them. Any function in which an independent variable is in the form of an exponent, they are the inverse functions of logarithm. Example, y equals b raised to x can be rewrite into logarithmic form as y equals log x base b.
The second function is the logarithmic function. Logarithmic functions are the inverses of exponential functions. A logarithmic function is a function of the form log base b of x equals y. Application of logarithmic function in chemistry. What is pH? P stands for power, while H stands for hydrogen ion. It is a measure of the strength of the acid or base character of a substance. But what is acid? An acid is a chemical species that donates protons or hydrogen ions. And what is a base? Well, a base is a substance that can neutralize the acid by reacting with hydrogen ions. In order to easily manage the wide range of ion activities, a logarithmic pH scale is used. The pH scale is logarithmic. The pH scale increases or decreases of an integer value, changes the concentration by tenfold. The logarithmic function that can be derived from this is pH equals negative log H plus ion concentration. Here I present some sample problems. The first given is H plus ion concentration equals 2.8 times 10 to the negative 4 molar. We use the formula pH equals negative log H plus ion concentration. Then we substitute the given to the H plus ion concentration, and then we got pH equals 3.55. Now the second problem, we use pH equals negative log H plus ion concentration. But here we can see when the first number here is 1, then the pH is equal to the positive value of the superscript. Do also take note that if you end up with the negative pH, you would need to change it to make it a positive pH, since a negative pH does not exist. Here's an example graph of the pH scale. The dependent variable is pH and H plus ion concentration, while the independent variable is the solution. The inverse of this function is pH equals 10 raised to the negative hydrogen plus ion concentration. From pH equals negative log H plus ion concentration, we will replace every pH with an H plus ion concentration, and every hydrogen ion concentration with a pH. Then transpose the negative to the other side. Using this equation, we can solve for pH by cancelling out the logarithm. We will raise both sides to exponents of 10, and since 10 raised to log can be cancelled, the final equation then becomes pH equals 10 raised to negative hydrogen plus ion concentration.
Next, we have the rational function. It is defined as the quotient of two polynomial functions in which the polynomial of the denominator is not equal to 0. Application of rational function. In calculating the density, we use the formula P, or density, is equal to mass divided by volume. In this sample problem, M is equal to 320 grams, which is why the dependent variable is the density, because its value varies depending on the independent variable, which is the mass. As we can see on the graph, the curves on the first and third quadrant approach the x and y axis, but do not intersect with them. Therefore, this function has no zeros, and its vertical and horizontal asymptotes are 0. The domain and range of this function are negative infinity to 0, union 0 to negative infinity. The inverse of this function is still p equals m over v. From this, we will replace every p with a v and every v with a p. And next, we will solve the equation for p. Let's transpose p to the left side. And lastly, transpose v to the right, and then we'll get p equals m over v.
The fourth and last function is the trigonometric function, also known as circular functions. Can be simply defined as the function of an angle of a triangle. The basic trigonometric functions are sine, cosine, tangent, cotangent, secant, and cosecant. Bragg's law is a type of trigonometric function because the steps taken to arrive at the answer are the same as that of the function. The independent quantity is the wavelength, while the dependent quantity is the angle of reflection. The domain is all real numbers, and the range is all real numbers from negative infinity to infinity. There is no inverse function for the problem. The graph of the function is increasing. The function does not have any zeros nor asymptotes. We are CHEMATHRY, and these are our members. Thank you for listening.